Hey there. Today we're looking at solving problems using TRIG, and we've done some of this already. This is really more than anything some review, but I thought I'd go over a few things with you first. When we're solving problems, a lot of times we have to draw a picture to kind of understand what's going on, and somehow or the other it creates this right triangle. A couple words that we use: angle of elevation and angle of depression. We always base it off of line of sight. So when you're looking straight ahead, if you're looking up at a plane, this would be your angle of elevation. But if you're looking down, he's at the top of a hill looking downward, your angle of depression is looking straight ahead down. We have to be careful with that angle of depression. So often we would draw a triangle right here and call this the angle of depression. And that's not actually the spot where the angle of depression is. What we do have, though, is a nice right angle. If we know this angle, well, we know it's complementary to this angle, and vice versa. We can get to what we need, but you have to remember that this would not be your angle of depression here. Now, as we do these problems, it's going to be a review of a couple things. It's going to be a review of SOHCAHTOA, but it's also going to be review of our special right triangles. So real quick, I'm going to review that. Remember that in a 30, 60, 90 triangle, where this angle up here is 30, it's across from your short leg. Whatever your short leg is, your hypotenuse is always twice that length, and your long leg is always that times the square root of 3. That's in a 30, 60, 90 triangle. If you already know the hypotenuse, you can divide it by 2 to get to your short leg, or if you already know the long leg, you can divide it by the square root of 3 to get to the short leg. The other triangle is the 45, 45, 90 triangle. In a 45, 45, 90, it's an isosceles right triangle. Those two legs are A, or whatever you want to call them. The hypotenuse is always that leg times the square root of 2. If you already know the hypotenuse, then you divide it by the square root of 2 to get to your legs. As we solve these problems, if it's a 30, 60, 90 or a 45, 45, 90, we're going to use what we know about special right triangles. If it's not one of those, then we're going to use SOHCAHTOA. We're going to start off looking at this example. A pole that has a height of 20 feet. All right, let's fill that in. This flagpole is 20 feet. And it has a shadow of 20 feet. That's this area along the ground. That's 20 feet. Find the angle of elevation to the sun. I'm looking for this angle of elevation. Hopefully you notice on this, oh gosh, this leg and this leg are the same. I have a right angle. This is really a 45, 45, 90 triangle, which makes finding theta pretty easy. Theta is going to be a 45 degree. See how easy this is? This one's a little trickier, though. It says two towers face each other, separated by a distance of 40 meters. So these two towers have a distance across from one another 40 feet. As seen from the top of the first tower, the angle of depression to the second tower's roof is 30 degrees. And it's 60 degrees to its base. Okay, this is going to get a little bit messy looking. From up here on the top of this, let me change that to black so you can see it better. Okay, so right here, up at the top, looking, now think if you were standing up on a tower up there, here is your line of sight across the top. That's your line of sight. And you're going to be looking down at the top of the tower. So we're going to create a little triangle here, like that. And it says looking to the second tower's roof, that angle of depression is 30 degrees. That means this is 30 right here. But more importantly, for me, that means this is 60. And I have myself a nice little 30, 60, 90 triangle. In addition to that triangle, I have a second triangle because it's, and I'm going to draw this in red so you can see it a little bit better. Now I'm looking to the base and creating this triangle. On this one, the angle of depression is 60 which then would make the angle in here 30. And I have another 30, 60, 90, just oriented differently and a different size. Okay, let's look at what we can figure out, what our goal is. Our goal is to find the height of the second tower, this height here. Well, if I look over at the bigger tower, I know that I'm going to be able to find all the sides in this black triangle, specifically this leg. And I'm going to be able to find all of the side lengths in the red triangle, specifically this length. And what I'm really looking for is this right here. If I can find the whole length, find this length, subtract them, and I'll have the leftover right here. Let's work on it. Let's start with the black triangle. Now, of course, this isn't really drawn to scale. You need to recognize that if this is 60, the side across from it is going to be your long leg. This is 30. This is going to be your short leg. The only number, the only measurement, side length that I have is this 40. And this 40 is the distance across here, but it's also the distance across right there. This would also have to be 40 feet. And since that is going to be my long leg, I'm going to have to take 40 and divide it by root 3 to get to my short leg. I'm going to go ahead and rationalize that. 40 root 3 over 3 is going to be the short leg. Now let's look at the red triangle. This will be a little bit easier because we know our short leg is 40. Then our long leg has to be 40 root 3. That's your red long leg. And we said to find the missing piece, the height of that second tower, the shorter tower, I'm just going to subtract those. In my calculator, I'm going to take 40 root 3, and I'm going to subtract 40 root 3 over 3, and get kind of a decimal approximation for that. And you may have chosen to go ahead and get decimals for these anyway. What I end up with here, when I subtract, I have a 69.3 minus 23.1. I end up with 46.2 meters. Let's try again. Two men on opposite sides of a TV tower of a height 26 meters. We already know the height of the tower is 26 meters. The angle of elevation to the top of the tower is 45 degrees and 60 degrees respectively. These are our two men that are looking up at the tower. That's their angle of elevation looking up. Now, one thing that we have to recognize is that we said that it always comes from your line of sight, and of course my picture isn't drawn to scale, but line of sight looks like you're not including this chunk. We typically ignore our eye level height, even though we know it's about 5 feet possibly there. We typically ignore that unless they specifically tell us what the eye level height is so we can do something about that. I'm just going to ignore it in this case. We tend to ignore it when you're talking about things that are super tall. So I'm looking at this triangle, but I'm also looking at this triangle. The angle of elevation of the two guys is 60 degrees and 45. And it really, for the picture, it doesn't really matter, but I would say that this looks like a bigger angle, so I'm going to call that one 60, and then I'm going to call this one 45. And you should recognize those are going to be special right triangles. On a right triangle, so the 45, this leg and this leg are the same. And we're going to know that that tower is 26 meters, so I know this is going to be 26 meters as well. Remember, we are kind of ignoring this business here. In the right triangle, the black triangle, when you look at that, the 26 is actually going to be your long leg. I need to divide that by root 3 to get to the short leg. If I want to get a decimal approximation, that's about 15.01. And I'm supposed to find the distance between the two guys. Well, once I know those two measurements, I can pretty easily figure out the distance there. Just add them up, and you end up with 41.01 meters. The two guys are standing apart. All right, let's try the one where the boy's looking up at the sky, up at the kite. So you're talking angle of elevation. You're looking upward on this one. And again, we're going to kind of ignore his eye level height and just draw in the triangle that it creates. It says the height of the kite is 24 meters. The angle of elevation, oh, well, it says with the ground. I guess I could redraw that then and make it actually work with the ground versus his eye level height. .30 degrees, 24 meters. Can you figure out how long the string is that he has let out? It's a 30, 60, 90. Again, not drawn to scale, but if this is 30, then this is my short leg. And that makes life a little bit easier. If the short leg is 24, you take it times 2 to get to the hypotenuse. 48 meters of string. All right, we're going to change modes here. Now I'm going to start looking at things having to do SOHCAHTOA. You can see here I got a 20-degree angle, so these are not going to be special right triangles anymore. You're in a hot air balloon, so there's somebody sitting up here in this hot air balloon. We know that it's 600 feet above the ground, and you can see your friend down here. If the angle from your line of sight to your friend is 20 degrees. Trying to help you out there. And we know how high it is, and we're going to be looking here. So I'm trying to tell you that from my line of sight to there is 20 degrees. Now, if that's 20, what I'm really going to be using is this as my 70 degree, because I know they're going to add up to 90. They're complementary. And we know that the balloon is 600 feet in the air. The question is, how far is he from the point straight below the balloon? There's your X. After you fill in all your information, you need to decide, is this a sine, a cosine, or a tangent scenario? From my angle that I know, I have adjacent, and I'm looking for opposite. That's tangent. Tangent of 70 degrees is equal to opposite over adjacent. You're just going to type in your calculator, tangent of 70, multiply it by 600, and we get 1,648.49 feet. Okay, another one. This one is very similar, but we're looking for something different. This time we are looking for that angle of elevation rather than us knowing what it is. We happen to know that the tree is 20 feet tall and that we are 50 feet from it. So we're going to, here's our nice right triangle. 20 feet tall. That's 20, this is 50. We're looking for the angle of elevation. From that angle that I'm looking for, I know opposite and adjacent. That means I'm going to be doing tangent, but I don't know what angle, so I'll do tangent of theta equals opposite over adjacent. And recall that when you are looking for your angle measurement, that's when you do inverse tangent or second tangent. In your calculator, you just type second tangent 20 over 50, 20 divided by 50. And you should end up with theta equaling a 21.8 feet. Not feet, it's an angle, degrees. And I lost my erase thing, so we scribble it and put a degree. One of the things, if you're not getting that, remember that when you clear your RAM, it goes to radians, and this is definitely a degree measurement we're looking for, so make sure you're in degree mode as you do that. And actually, as I say that, that may have been an issue all along for you. You need to be in, well, I guess that was our first SOHCAHTOA problem, but you need to be in degrees for these problems because everything's going to be degree measurements. You're on top of Pikes Peak looking down towards Colorado Springs. If the mountain is 114 feet tall, the city is 5.2 miles away. What is the angle of depression? So you draw in the triangle, but keep in mind the angle of depression is really going to be this angle, which is not in my triangle, but I can get to it. The other thing that you have to be careful about is when I say 5.2 miles, we can't have one side in miles and the other one in feet. So take that times 5,280, and you should get 27,456. And that's going to be the leg. And it looks like another tangent scenario. I'm going to look for this angle here. Tangent of that angle is opposite over hypotenuse. And then do inverse tangent on that. You should end up with a 62.79 degree angle. But recall that that's the angle here. That is not your angle of depression. You need to take 90 minus that in order to get the angle of depression that we actually want, which is right here. Final answer should be 27.2 feet. Nope, did it again. We are not finding a distance. We are finding an angle. Degrees. This is our last one. Trickiest one yet, sort of. It says the angle of depression from the pilot's point of view to the close end of the runway is 82 degrees. Looking down here, that's your angle of depression. That's 82. But we're also looking to the far end of the runway, way down here. And that angle of depression is less. It's only 74 degrees. But we know what the plane's altitude is. It's going to be right here. And that's 2,000 feet. I'm going to have two triangles going on again. I'm going to have my red triangle here. And then I'm going to have the blue triangle isn't really a right triangle. I have to drop this down right here this way and turn it into a right triangle. There we go. So I'm going to do the blue triangle, I'm going to do the red triangle. Keep in mind what we're looking for. How long is the runway? That's this distance right here. This is going to work just like the two towers problem did, where I'm going to find this red length here, I'm going to find this blue length, and if I subtract them, then I'll have this missing piece here. Starting with my red triangle, I had an angle of depression of 74, totally not drawn to scale. What I need is the rest of that angle, because that's in the triangle. 90 minus 74 would be 16. I'm going to be doing tangent again of 16 is equal to my opposite side. Opposite side is this, which I do not know. Let's call it, I'm going to need a lot of letters here. I'm going to use that as a z. Is equal to z over 2,000. Take the tangent of 16 and multiply it by 2,000. Z is going to be 573.49 feet. Then I'm going to do it again with the blue triangle. And once again, this is 82. What I need is its complement. The complement of 82 is just this piece here, which is 8 degrees. So same setup, tangent of 8 is going to equal, okay, so this time I'm only looking at this piece. I'm going to call that y. Tangent of 8 times 2,000 gets me 281.08. And if I take my z and subtract the y, I'll end up with x, the length of the runway. X is 292.41 feet. All right, hope this helps.